Welcome back. We're looking at solving inequalities by the intersection method. Before we get into using the TI to do this, the most important part for you to understand is how to interpret the graph in order to solve these inequalities. So I have the first few examples here where we're looking at the lines that we assume have already been graphed by our TIs. And look at, we have Y1 labeled in blue and Y2 labeled in red. And what I'd like to do for myself is always label them on both sides. It may be easier to visualize later as to, we're looking at which Y value is higher than the other Y value. So it's a nice little tip there. And if you remember from section 1.5, before we can do anything in terms of interpreting these graphs, we need to figure out where is Y1 equal to Y2. So we need to first find the X value. Y1 is equal to Y2. So that is done if we're going to press a series of buttons on our TI to find the intersection. And we could actually see the intersection right in front of us. And what's kind of nice is if we go through, they give us the actual intersection points with the TI, but just so that you know, I always map it down to the x-axis. And we see that x is equal to 3. I'd like to label it for myself there. So we've just found where Y1 is equal to Y2. That's when X is equal to 3. And so now this allows us to now break up the X-axis into two different regions. We're going to look at the region with the numbers before X equals 3. And then we'll look at the X-axis for the region of numbers after X equals 3. So when we start to try to answer these inequalities for part A and part B, we're basically deciding, do we use the yellow region or the teal region for the most part? So in order for us to formally determine this, what I like to do is test points, just so that I can really interpret what my values are. So let's look at an X value in the yellow region. So any number that is smaller than 3. So if we do this, I'll just pick a random X value. I know sometimes you can count it and see if there's a nice axis there and you see we have a clear value. But it doesn't have to be a nice integer. It could be anywhere in the yellow region. So after I pick that test point, what I do is I look at where is the corresponding Y value to that test point. So usually you're either traveling up or down to reach your function. So in order to get Y1, the corresponding Y value would be at this orange point right here. And so if you wanted to label it, the X value would be 1, the Y value is Y1. In our case, it's kind of a little bit above, I think it was 3 or so, but we're not really concerned about the actual value of this Y. We just want to determine if it's higher or lower than that one of Y2. So we'll do the same thing. We'll travel upwards from our corresponding X value that we just picked. And we see that we hit the function Y2 a little bit higher. So this kind of tells me what I'm trying to understand is which Y value or which orange dot is higher than the other. And so when I kind of inspect it, I can actually see the X value that has the corresponding Y value that hit Y2 is higher than Y1. So we can kind of do this to say, okay, I think that might be one of the solutions to either part A or part B. You can even kind of write yourself a note if that's helpful, just so that we kind of can see for these 2 points. Here we have y2 is higher, greater than y1. And if you want to just make sure that you can kind of really interpret this, sometimes I have to do this a couple times to see what's going on. So I can always pick another value, if you guys don't mind. Here's another random x value. And where I want to look at the corresponding y value, I would have to travel upwards to see it's placed on the y1 function. And in order for me to see the corresponding y2 value, you kind of have to extend your line a bit. So that way, if we travel from our x value and we find the corresponding y2 value, we can also see that it's a lot higher than the y1 value. So in both of these cases, y2 is greater than y1. So if I try to kind of look at, is this going to be the answer to part A or part B, which is the intersection? We already have the 3, that's the nice boundary point. We're gonna look at what matches the inequality. So y2 is higher than y1, although it's not exactly the same thing as what we have right here in this yellow region. We can see the corresponding expression or statement would be this one. And that does mean the same thing. The inequality is opening up to the y2 and it's pointing towards the y1. So we could kind of say, okay, that means the yellow region is representing all the x values that make y1 less than or equal to y2. So the next thing we want to do is try to describe this solution. So I always kind of look at the example and I want to see, okay, do they want the answers in set notation or interval notation? And I'm kind of a fan of interval notation, so that's usually where my brain goes. But I'll always reread the directions at the end to double check. So it does ask me for interval notation. And so what I want to do is say, how do I describe that yellow region? And so I'll do that. So if we go through there, the yellow region is actually all the numbers from -infinity, stopping at x equals 3. And remember, with interval notation, infinities always have parentheses on it. And if we're looking at whether or not we should include a parenthesis or bracket on our boundary point x equals 3, the inequality symbol always gives us the clue. And because we have the less than or equal to, key being the or equal to part, that is why we're going to use the bracket. And so if you're writing this, make sure you're very clear as to whether you're using a parenthesis or bracket. We don't want to see any half parentheses or brackets. That's really confusing. So, be confident. And even if you make a mistake, you learn the next time. So the cool thing about these inequalities is that if you are trying to answer 2 parts, if you already know the answer to one of the parts and the part B is just kind of the reverse, you could probably automatically guess that the part B, all the x values in the teal region are going to describe what those y values are doing. But just to make it clear for yourself, it's always a great idea to make your test point to see if this is really true or not. So again, I will pick a random value in the teal region, and I will map my x value to find its corresponding y value. So in order to hit y1, my x value, I have to go up. That means y1's positive. And in order to hit my y2 value, I have to travel downwards. That means my y2 in this case is negative. It's below the x-axis. So here, if we're looking at it, we kind of say, well, which one has a higher y value? Is it y1 or y2? And we can see, oh yeah, the purple dot on top is a lot higher value than the purple dot on the bottom. So here, if we're kind of describing this, you can say, if you're looking at these 2 points and you're trying to compare them, you're saying, all right, this is telling us that y1 is greater than y2. And what's kind of cool, if you labeled the lines, you could also see, oh yeah, y1 is on top of y2. Now, if you're still not convinced, I always recommend trying another point. So maybe we just pick something a little closer to the 3, and you can map it to C. In order to hit y1, you have to go up a little bit more, still have a positive y1 value. In order to hit y2, you still have to go up. But when you still look at them, the higher y value, the purple dot, is going to be located and mapped to the y1 value. So in both cases, y1 is greater than y2. So if you kind of look at which inequality is describing that, we already kind of see it right here, part B. So now all we have to do is describe the region of those x values. So that is all the numbers from 3 and on up. So that would mean we'd start at 3 and stop at infinity. Infinity has a parenthesis. And this symbol is greater than or equal to. So that's where we're getting that bracket from. So that is the solution to these types of problems. And what I want to really emphasize is when you are writing your interval notation, these are actually describing the regions or the x values. So this describes the x values that make the inequalities true. For the y values. So a lot of time when we're first starting, it gets a little confusing because part A, part B, we're talking about y values, but remember the whole idea of this example, they wanted us to find the values of x that satisfy the inequalities. So just kind of be careful on that. And we'll definitely do another one to make sure you're kind of getting good at this. And the more you practice, the better off you're going to be. So let's do one more together. Look at this next one. So same directions. Refer to the graph of the linear functions y1, y2, and find the values of x. Sometimes it's nice to kind of remember what we're trying to do. That satisfy the following. And so we're looking at part A, y1 less than y2. Part B, y1 greater than y2. And what I always like to see when I'm going through these equations and such, I always like to label the lines on both sides. So I have y1 and y2, I'm just gonna map it on the other side. Now, if your calculator doesn't have color, that's okay. Just draw a quick sketch on paper and do what I've done right here. It's really nice to see. Sometimes it makes the numbers stand out as well. So first things first, we always have to ask ourselves, where is y1 equal to y2? Notice these inequalities are comparing the y1 and y2. And that is always when the two lines have the equal y value, and it is always at their intersection point. And right away we see, okay, the TI gives us the information, x equals -5, or we can actually count and see. And I always like to label, I kind of mark that particular x value on the x-axis itself, and I like to label it. Usually I label it beneath it, but I don't have any room. So y1 is equal to y2 when x is equal to -5. So that is what we call our boundary point. It kind of separates that x-axis up into two different regions, numbers to the left of -5 and numbers to the right of -5. So now your goal is to figure out which region describes which inequality, part A or part B. So I'll just start off with test points so I can interpret this, and then we'll see which one it maps to. So just kind of be careful. We're describing y values in part A and part B. We'll get back to that thought in a second. I'm going to pick a test point in the yellow region. So maybe I'll pick it over here somewhere. And what I want to do is map to both lines. So for that corresponding x value on that left side of the, I guess it's on the left of the -5, in order for me to hit the y1, I go straight up and I have a orange point on the y1. In order for me to hit the y2, I have to go down a bit in order for me to get that corresponding y2 value. So now if you were to have to answer a question, which y value is bigger? Who is higher than the other y value? And when I look at it, to me, I'm seeing that the y1 value is higher than the y2 value. So kind of what I'm always kind of asking myself, y1 is bigger than y2 in this case. And feel free, pick another point. Sometimes we're getting a little bit smaller, but I could pick one a little closer to the -5. And when I want to find the corresponding x value, you kind of see, oh yeah, I just map it down. And in both cases, the points that are located on the blue line are higher than the points that are located on the red line. So y1 on the left side of -5 is always higher than y2, or what we want to say formally, greater than y2. So if I'm trying to determine which inequality matches this, I can see right away part B is describing the same thing, y1 greater than y2. So might as well answer the question. If we're going to go through this, we're going to describe all the x values in the yellow region. So that's all the numbers to the left of the -5. So we're going to go from -infinity to -5. Infinity always has a parenthesis. And then just remember that this inequality symbol is just the greater than. So there's no equal to part. So that's why the -5 is going to have a parenthesis. So now you're pretty much halfway done. And the trend of these ideas is if you already know that the yellow region is describing part B, automatically you can say, because the inequality symbols are flipped around, the teal region must be describing part A. But let's just do the test point, bear with me just so that we can visualize why are we answering the questions the way we're doing. So let's pick a test point in the teal region. And in order for me to hit the corresponding y2 value, I have to map it upwards. In order for me to hit the corresponding y1 value, I have to map it downwards. And if you want to do this one more time, just to kind of see, pick another value. And I can't quite see the y2 value. So that means I probably have to extend the line a bit just so that I can go there. And we're totally allowed to do this. Your paper, right? So there I have the y2 value. In order for me to get the y1 value, I have to map it downwards. So now what I'm trying to understand, when I'm looking at each particular x value, what point is higher? Is it the one on the y2 or is it the one on the y1? In both cases, these purple dots are higher. So what I'm trying to describe what's happening to the y values, my y2 values are always greater than my y1 values here. So when I'm trying to describe this and I look at it and I'm like, that doesn't quite look like part A. But if you kind of look at the way the inequality is facing or opening up towards, in both cases, it's opening up to the y2 and pointing towards the y1. So these are equivalent statements, by the way. Sometimes that confuses us. So if you prefer, you can kind of really take time to think about that. So now you just want to answer that question. How do we describe that teal region? It's kind of a nice one-dimensional number line now. All the numbers from -5, let's make that prettier, to positive infinity. And infinity always has the parentheses. And this is a less than symbol. And there's no or equal to involved. So this is why we're using the parenthesis. So we feel pretty good about ourselves. We answered the question. Before you move on to the next question or press that submit button on your test, always double check the directions. We are looking at referring to the graph of the linear functions y1 and y2, and we are finding the values of x that satisfy the inequalities. So the inequalities are describing what's happening to the y values, and these are describing what happens to the x values. So I'm feeling pretty good about that. Cool. And then just make sure it's asking us to write our answers in interval notation, and it looks like we did that, so we are good to go. So I strongly encourage you practice interpreting the graphs before you even move on to using your TI to solve these. The TI is just a matter of pressing buttons to get your intersection point. And after that, it's just interpreting graphs. So if you understand how to do these two examples we went over, you'll be pretty good at going through these with the TI. I do have some extra practice worksheets involving interpreting the graphs, so check that out. And hopefully this helps. So I'll see you next time.